Hello, and welcome to this CS5744 presentation on microservices, a scalable approach to software architecture by John Tran. You might be asking, what is a microservice? A microservice is an approach to designing software applications as suites of independently deployable services. In traditional software architecture, you have a system that's centralized, monolithic, typically written in one language or framework, and is difficult to modify or evolve after it has been established. In contrast, microservices are lightweight, they are swappable, they are easy to modify, and they share across different platforms, and they are independently deployable. Martin Fowler and James Lewis summarized the microservice architecture as an approach to developing a single application as a suite of small services, each running its own process and communicating with lightweight mechanisms built around business capabilities and independently deployable by fully automated deployment machinery, with a bare minimum of centralized management which may be written in different languages and use different storage technologies. The diagram on the left shows a client-service architecture where the client interacts with an application programming interface, or API, that communicates with services that can be independently launched. This takes us to our first pause and think question. Can you think of a few examples of monolithic applications? I'll give you 5 seconds, starting now. Okay. One small example of a monolithic application I've encountered is the way one downloads the package manager for a popular IDE called Sublime Text. Believe it or not, this whole code is supposed to be a one-liner. It is all supposed to be executed as a single long line of code in the terminal. Can you imagine if you needed to add or update functionality to this code? Yikes. We can see how breaking down a monolithic service, like downloading a package, into smaller parts can improve readability and maintainability in just this simple example. There are 9 characteristics of microservices. Because we have a limited amount of time, I will go through most, but not all, of the characteristics on this list. The first one is componentization via services. We have learned about components in this class. Components make our applications more modular by encapsulating functionality into well-defined interfaces, which allows them to be independently replaceable and independently upgradable. A good analogy are the parts underneath the hood of your car, such as the battery, radiator, intake valve, and lights, that can be upgraded or replaced as needed without affecting the other parts. When looking to split a large application into parts, managers often focus on dividing teams based on technology. The database team sits here, the service team sits here, the UI team sits here. In contrast, microservice architecture is organized around a company's business, not its technology stack. The sales department will have its own team of database, server, and UI engineers. The marketing team will also have dedicated engineers that specialize in their specific business capabilities. Team members are cross-functional and can move around between sales, marketing, and other parts of the business where skills are needed. This allows everyone to have a diverse understanding of both the technology and the business. The traditional stance on software architecture is to create a centralized store for databases, which interacts with a centralized store of middleware, such as web servers, which manages communication with the front-end application. Communication between services in this architecture is hierarchical. In contrast, the philosophy that microservices adopt is to have each service be responsible for encapsulating its own environment and execution context, such that each microservice is independent of any other service. This allows one service to be written, say, in Java, and another service to be written, say, in C#. As long as each microservice has a well-defined interface, it doesn't matter what the internal runtime environment of each service is. This makes microservices loosely coupled, swappable, and containerized. This also makes the software system designed for failure. The responsibility of any one microservice can be distributed across multiple copies, which allows for load balancing. In addition, data can be replicated across multiple nodes or clusters. If one server is destroyed, there are multiple replicas of this data elsewhere, and the data is not lost forever. Lastly, microservices adopt an evolutionary design that continuously evolves as the system evolves. We typically begin an application as a prototype with a small set of users. As the application becomes more popular, the decisions made for a small application might gradually become inappropriate for thousands or millions of users. Additionally, the application might evolve from being deployed on a desktop environment to being deployed on cloud or mobile devices. A good analogy is that the decisions you make to construct a doghouse are not the same decisions you would make to construct a skyscraper. It's not an issue of just buying more wood. We need a design that can continuously evolve as our application evolves. To learn more about microservices, visit Martin Fowler's website. Martin also has a great talk that he gave at the Go2 conference in 2014, whose YouTube video I've linked. Also, Susan Fowler is a site reliability engineer at Stripe and formerly at Uber, who has written a great book on how to build production-ready microservices. I hope you enjoyed this presentation on using microservices as a scalable approach to software engineering.